Hello everyone, I am Joseph Moore, and today I'm mad because I took a physics test and I had a very difficult time with it. So, without further ado, I'm going to complete that test right here. Imagine the situation. Two brothers are situated above a platform 20 meters above the ground. There's a UFO sucking the air out of the environment, so there's no friction from that. One brother is throwing the ball down at negative 14.7 meters per second, while the other brother is throwing the ball up at the same speed. Our question now becomes, what is the difference in time from the first ball hitting the ground to the second ball hitting the ground? This means that we can plug in our values into the equation y equals y0 plus v0t plus 1 half at squared. What, you don't know that equation? Here it is. Okay, we start with the fundamental equations. Change in x is average velocity times time. Average velocity is velocity plus velocity 0 times time, and velocity is equal to velocity 0 plus a times t. After substituting v plus v0 over 2 equals average velocity into change in x equals average velocity times time, we get the equation that we mentioned before. Now, this equation only works with you have constant change in acceleration, or no, not constant acceleration. You need a constant change in velocity. Anyway, you plug in negative 10 as the acceleration due to gravity and negative 14.7 as the initial velocity, and you get 1.01 seconds for time 1 and 3.95 seconds for time 2. Subtract these times to figure out the time between when the balls hit the ground. So that's an answer for part 1. Let's move on to part 2, which is what velocity were both balls traveling at when they hit the ground? You can find this by plugging into the equation v squared equals v0 squared plus 2a delta y. You get this equation by the fundamental equations at first, but then you just substitute differently. V minus v0 over a is equal to t. You get that from deriving the equation above it. You substitute into the change in x, and then you just multiply it together, and then subtract the y x over, and you got it. If you're not following along, just pause the video or look it up somewhere else. I really don't care. So this expression is your simple plug and chug sort of thing. What you need to do is just plug in the numbers, and actually both balls will be hitting the ground at the same velocity, though at different times. If you think about it, they left the hand at the same speed, and by the time the ball traveling upwards gets to the point where it's traveling downwards, it will be traveling at the same speed as when the other one left it. So it will be accelerating at the same rate, and it will hit the ground at the same velocity. And now we're moving on to part C. The question is, at time t equals 0.8 seconds, what distance are the balls apart from each other? And plugging into the equation y equals y0 plus v0t plus 1 half at squared, we get the expressions minus 14.96 meters, y equals 8.56 meters for the second ball. We add these together and get 23.92 meters. There! I can do that.